Hello class, today's lesson is going to be 6-3, learning how to solve linear systems by adding and subtracting. Now, the past couple lessons were solving linear systems. The first one was by graphing both of the lines and finding the point where they meet, and that was the solution. Yesterday's lesson, though, was solving linear systems by doing substitution. So we were rewriting the equations and trying to solve for one variable and then plugging it in, and it was a lot of work. But sometimes you're going to be able to solve a linear system with just a little bit of work, and it's going to be either by adding or by subtracting. And what we're trying to do is we're trying to get rid of one of the variables, either both of the x's or both of the y's. In this case, I can see that the coefficient in front of the x's is both the number 2, except one of them is a -2. If I was going to add these two linear systems together, I'd have a big plus sign. Okay, so that's going to be my addition. Okay. And when I combine both of these equations, what I'm going to do is I'm going to add straight down in the column. So 2x plus -2x is nothing, right? That is 0. They cancel each other out. So I have already eliminated one of the variables. 3y plus 5y is 8y. And then also going down in the column, 11 plus 13 is 24. Okay, so really, I've now eliminated the x's completely, and all I have left is 8y equal to 24. Now, to get the y by itself, I'm going to divide both sides by 8, and y is going to be 3. So in my coordinate for my solution, I've already found the y value. It's 3. Now, like you did yesterday with substitution, I can use this and plug it back into one of my equations to find the x value. It doesn't matter which one you use. I'm just going to use the first one, which was 2x plus 3y equals to 11, and I'm going to plug in the y value to find the x. So I'm left with 2x plus 3 times the y is 3 equal to 11. That is 2x plus 9 is equal to 11. I'm going to subtract 9 on both sides because I want to get the variable by itself. So I'm going to get rid of that lonely number. I'm left with 2x is equal to 2. Get the x by itself, so divide both sides by 2, and x is equal to 1. That's going to be what I'm going to put in the x value for my coordinate up above. And I have found my solution. And I did this just by adding both of these equations together, and it actually eliminated that variable. So just like we did before, let's just check to make sure that our solution is a solution for this linear system. So we do that by plugging in the coordinate 1, 3 into both of the equations that we started out with. So I have 2x plus 3y is equal to 11. For the x, I'm going to plug in 1, and for the y, I'm going to plug in 3. 2 times 1 is 2, 3 times 3 is 9, and 2 plus 9 is 11. So the first one worked. Let's just double check to make sure that the second equation works as well. I have 2x plus 5y is equal to 13. I'm going to plug in the x, which is 1, and for the y, I'm going to plug in 3 equal to 13. -2 times 1 is just -2, plus 5 times 3 is 15. -2 plus 15 is 13. So that is the same number on the left and the right hand side. So this first time I did my solving of the system through addition. The next one we're going to do is going to be very similar, but instead of addition, I'm going to do subtraction. Notice that I have a 3y in both of them. So if I was going to subtract one of these equations from the other, that would eliminate the y's, right? Okay, so I'm going to do subtraction here. The thing to notice, though, when you are doing subtraction is that really you're going to do minus 5x, minus 3y, and minus negative 2. So just make sure that that minus sign is going to be attached to all of the values in that whole equation. So 4x minus 5y is negative x. 3y minus 3y is 0. And 2 minus negative 2 is the same as 2 plus 2, which is 4. Okay, so really I have negative x is equal to 4. I'm going to divide both sides by negative 1. Why do you ask? Because in front of this negative x, there really is a 1 there. So that's how I'm going to get positive x is equal to negative 4. So that means in my solution for my coordinate, the x value is negative 4. So let's go ahead and take this. Let's plug it into one of the equations up above. It doesn't matter which one, but I'm going to try to get the y value now. So I'm going to just use the top one, 4x plus 3y is equal to 2. I'm going to plug in, instead of x, I'm going to put the negative 4 plus 3y is equal to 2. 4 times negative 4 is negative 16 plus 3y equal to positive 2. Sorry. Add 16 because that is the lonely number. 3y is equal to 18. And I'm going to divide both sides by 3. And y is positive 6. So I have now found my y value. So I think that I have successfully solved this linear system. Just to be on the safe side, let's check to see if when I plug in the x and the y value into both of these equations, that it does in fact work out. The first one was 4x plus 3y is equal to 2. So 4 is equal to, or 4 times negative 4, sorry. And then the 3 times 6 is the y value, is equal to 2. That leaves me with negative 16 plus positive 18 equal to 2. And 2 does in fact equal 2. On my right-hand side, I'm going to do the second equation. It was 5x plus 3y is equal to negative 2. Let's plug in. The x is negative 4, and the y is positive 6. Let's see if that is going to be equal to negative 2. 5 times negative 4 is actually negative 20. 3 times 6 is 18. Negative 20 plus positive 18 is negative 2. So it's the same on the left and the right-hand side. So again, I successfully solved this linear system, and all that I did this time was subtract one equation from the other. I just lined them up, all right? I had gone straight down in a column to eliminate the y's. We're going to do one more example. This time, we're going to solve this linear system the same way. I don't know if it's going to be addition or subtraction, right? But I do notice that the x's, they don't have the same coefficient. This is a 9, this is negative 7, but the y's both have the same coefficient of 3. One of them is a negative 3, but this one is a positive 3. So I think that I can eliminate them. What you need to do first, though, is to rewrite the second one so that the x and the y are both on the same side. So I'm going to do that by adding 7x to both sides. So if I rewrite it to have the x's come first, it's going to be 7x plus 3y is equal to 30. Okay. And then I can just move the top equation back over. 9x minus 3y is equal to 18. Okay, so now I have the x's in a row, or in a column, the y's in a column, and the variable or the numbers by themselves in a column. So what do you think I'm going to do? Am I going to do addition or subtraction? Well, since this is already a negative 3 and this is a positive 3, I'm going to do addition. Okay. And I really, really like doing addition because you just go straight down. You don't have to worry about any negatives. So 9x plus 7x is 16x. The negative 3y and the positive 3y add to 0. And adding 30 plus 18, I'm going to get 48. Okay, so I have 16x is equal to 48. I don't need to have it with the 0 in there. To get the x by itself, divide by 16. And x is going to equal 3. So I have found my first part of my coordinate. It is 3 in the x value. I'm going to use this and plug it into either one of the equations. I just always choose the top one, but I would just use whichever one looks easiest to you. Plug in my x value, which is 3. So I now have 9 times 3 minus 3y is equal to 18. This is 27 minus 3y is equal to 18. Subtract 27 on both sides because I want the y by itself. Left with negative 3y. Make sure you still have your negative there. 18 minus 27 is negative 9. Now I'm going to divide both sides by negative 3. Y is equal to negative 9 divided by negative 3 is positive 3. And I found the second part of my solution. So I now have the coordinate 3, 3. I think that I found my solution. So let's do one more check. Plug it in to both of the equations. So 9x minus 3y is equal to 18. Let's see here, 9 times 3 minus 3 times 3. Is that equal to 18? Well, that's 27 minus 9. And 27 minus 9 is 18. It's the same on the left and the right hand side. Let's just check the other equation. I have 3y is equal to negative 7x plus 30. Plug it in. 3 times 3 is equal to negative 7 times 3 plus 30. The left-hand side, 3 times 3 is 9. The right-hand side, negative 7 times 3 is negative 21 plus 30, and that is 9 as well. So I did find my solution, and I just did it through addition. I added both of the equations, but the important thing in this time was that I had to rewrite one of the equations before I was able to do any addition. So for your homework, before you come into class, I want you to try one on your own. I want you to solve this either through addition or subtraction. You have 3x plus 4y is equal to negative 6, and you also have 2y is equal to 3x plus 6. So let's look to see which variable you think you're going to be able to get rid of, and if you're going to have to do any rewriting of the equation before you actually add or subtract. So come to class with any questions you might have.